Introduction. Students, this is right-angled triangle. Can you tell which side is the hypotenuse? C is the hypotenuse. Yes, C is the hypotenuse. So by hypotenuse theorem, C square is equal to A square plus B square, we will prove some trigonometric identities. Teacher, what is a trigonometric identity? Today I will teach you about trigonometric identities. Come, let's learn. Objectives. At the end of this lesson, you'll be able to define trigonometric identity, understand reciprocal identities, understand Pythagorean identities, prove Pythagorean identities, solve examples related to Pythagorean identities. Definition. An identity is an equation which is always true. These can be trivially true like x is equal to x, or usefully true such as the Pythagorean theorems a square plus b square is equal to c square for right triangles. Trigonometric identities are equalities that involve trigonometric functions and are true for every single value of the occurring variables. Geometrically, these are identities involving certain functions of one or more angles. They are distinct from triangle identities, which are identities involving both angles and side lengths of a triangle. Reciprocal identities. Look at these identities now. Cosec x is equal to 1 by sin x. Sin x is equal to 1 by cosec x. Sec x is equal to 1 by cos x. Cos x is equal to 1 by sec x. Cot x is equal to 1 by tan x, which is equal to cos x by sin x. And tan x is equal to 1 by cot x, which is equal to sin x by cos x. These identities are the reciprocal identities. Pythagorean identities. Have a look at these identities. Sin square theta plus cos square theta is equal to 1. Tan square theta plus 1 is equal to sec square theta. Cot square theta plus 1 is equal to cosec square theta. These identities are the Pythagorean identities. Proof of Pythagorean identities 1. Now we will prove one Pythagorean identity and use it to prove other identities. For that we take a right-angled triangle ABC. By Pythagoras theorem, AB square plus BC square is equal to AC square. Now dividing each term by AC square we can write it as AB upon AC whole square plus BC upon AC whole square, which equals to AC upon AC whole square. That is, cos square A plus sin square A is equal to 1. This is true for all A such that 0 degree is smaller than or equal to A, which is smaller than or equal to 90 degree. So this is a trigonometric identity. Proof of Pythagorean identities 2. Similarly, we will prove these two identities. In right triangle ABC, by Pythagoras theorem, AB square plus BC square is equal to AC square. Dividing all the terms by AB square we get, or we can write it as AB upon AB whole square plus BC upon AB whole square equal to AC upon AB whole square. That is, 1 plus tan square A is equal to sec square A. This is true for all A such that 0 degree is smaller than or equal to A, which is smaller than 90 degree. Proof of Pythagorean Identities 3. The last identity is cot square theta plus 1 is equal to cosec square theta. To prove this, we will again take a right triangle ABC. So, by Pythagoras' theorem, AB square plus BC square is equal to AC square. Dividing all the terms by BC square, we can write it as AB upon BC whole square plus BC upon BC whole square is equal to AC upon BC whole square. That is, cot square A plus 1 is equal to cosec square A. We know that cosec A and cot A are not defined for A is equal to 0 degree. Therefore, it is true for all A such that 0 degree is smaller than A, which is smaller than or equal to 90 degree. Example 1. Let's now solve some examples related to trigonometric identities. Prove that tan x sin x plus cos x is equal to sec x. To prove this, we will use the fact that sin square x plus cos square x is equal to 1 for all values of x. On solving the left-hand side, which is tan x sin x plus cos x, we get sec x, which is equal to RHS. Hence, tan x sin x plus cos x is equal to sec x. Example 2. Prove that sin raised to the power 4x minus cos raised to the power 4x whole upon sin square x minus cos square x is equal to 1. Solution. On solving the left-hand side, which is sin raised to the power 4x minus cos raised to the power 4x whole upon sin square x minus cos square x, we get 1. And this is equal to right-hand side. Hence, sin raised to the power 4x minus cos raised to the power 4x whole upon sin square x minus cos square x is equal to 1. Did you know? The trigonometric identities are derived by expressing the sine or cosine of a sum of difference of angles in terms of the sines and cosines of the individual angles. The identities are true whenever they are meaningful, which distinguishes them from equations which are true only for particular values of x. Claudius Ptolemy, one of the most influential Greek astronomers, was developing the identities in terms of chords of a circle or arcs as early as about 130. He showed that he knew one of the most important identities, sin x plus y is equal to sin x cos y plus cos x sin y, although instead of writing it in terms of sine and cos, he used chords, as they did in those times very early in his career while studying astronomy. Summary. Let us summarize what we have learned. Trigonometric identities are equalities that involve trigonometric functions and are true for every single value of the occurring variables. Sin square A plus cos square A is equal to 1. Sec square A minus tan square A is equal to 1 for 0 degree is smaller than or equal to A, which is smaller than 90 degree. Cosec square A is equal to 1 plus cot square A for 0 degree is smaller than A, which is smaller than or equal to 90 degree.